Hello guys, what's up? We are back again with another question from our level up series. So guys, let's get started. So today our question is Russian doll envelopes. Now let us first understand what this question states and then we will proceed. Okay, just a second. Now in this question, we are given a 2D array of integers envelopes where envelopes of I is wi, height I, and yeah. So basically, we are given you can say a vector of pairs. In this case, they are given in the form of vector of vectors, but we can state that we are given yes, vector of pairs in which there is a wi and a hi. So every pair has some width and some height, and we need to find the maximum number of envelopes we can put inside the other. Yes. So basically what we need to find is okay. So let us understand it by example. Let us understand it by example. What actually we need to find. First of all, we need to have clarity on that. So for example, I have this envelope set. There is one envelope of width 5 and height 4, then width 6 and height 4, and so on and so forth. So what I need to do is, okay, let us say I take this 2 comma 3 envelope. Then I took a bigger one and I fit 2 comma 3 into that. Now what is the condition of fitting in? The condition of fitting in is that width and height both should be greater. For example, I can fit 2 and 3 into 5 and 4. Yes. 6 and 4. Yes. 6 and 7. Yes. But I cannot fit 6 and 4 into, but I cannot fit 6 and 4 into 6 comma 7 because their widths are same. So I cannot fit it. So I need to find, essentially, I need to take one envelope. Okay. Just a second. I need to take one envelope and I need to find maximum how many envelopes I can fit in. That's what I need to find. Maximum number of envelopes you can put inside one another. It is not like that maximum number of envelopes I can find by taking 2 comma 3, then 5 comma 4, then 6 comma 4. No, it is not like that. It's like you have to form a sequence that I can take this, then this, then this, then this, then in this way, I will be able to cover maximum number of envelopes. I need to find that sequence. And once you think about that, you can start thinking in the direction of generating a sequence in a particular manner. And that's when you will be inclined towards using something like LIS or the sort of that approach. Now, how you will use that? Okay, so naively, what first you will think is that I will sort it. For sure, you can sort it. The constraints also demand, say like that. Yes, you can sort the array. But sorting a 2D array also demands you to make your own custom function. Now, hence, what I thought was, I will sort it according to, let's say, I can sort it according to any parameter. Let's say according to width. So width is sorted. So I have my envelopes arranged in a manner such that the lower width comes first and the upper width comes next. Now I have no issues with the width. If the width is same, then I can sort it according to, yes, height. Then I can sort it according to height. Then according to height, I can sort it. That is clear. So what I need to now see is that I have my width sorted and I need to just see the heights. And if the height is greater, that means I can take it. That means I can take it and I can form a sequence. I can form a sequence out of it. So then it turns into simple LIS problem. But you will find that neither tabulation, neither memoization and the tabulation which you directly convert that memoization into tabulation works. No, you have to use binary search tabulation. Since it gives in n log n. And n log n is for sorting as well. So there is an n log n for sorting and n log n for this. So otherwise it would have been taken n square. It would have been taken n square and memory limit exceeded as well you will encounter. Yeah, is it clear? So we need to sort it according to the width. If the width is same, then sort it according to height. It turns into the simple LIS problem. Then we can use binary search and it gives answer in log. So now let us just go through the code as this is, I think, pretty much clear to everyone. So yeah. Code is more or less the same. So I will sort it according to width. Yes, this is my comparison function. And clearly you can see if the widths are equal, then I'm sorting it according to the height. Now I will directly use the concept of binary search implementation of LIS and I will sort it according to the heights because widths are already sorted. I need not care. If I'm moving from, let us say, index I to index I plus 1, then I know that if either the widths are same or what, or the widths are less, means arranged in a ascending order. Okay. Now here is one catch. If the widths are same, then I cannot take that element. Agreed? Hence, what I have done is that I have sorted them according to their heights in descending order. LIS won't track widths. So if the widths are same, then I need to keep them in such a way. That LIS won't count that because I'm applying LIS only on heights. So if the heights are same, then what I will do, if the widths are same, then I will take the element with bigger height first. So that it won't matches with the smaller height. Is it clear? Yes. Now it is very simple LIS in which we push the first element, then we check for the array. If the element is greater than because we maintain a sorted track here, then we push it into the element, push at the end in the temp array. If it is not, then we calculate the lower bound and we push that into the array. We replace that into the index of the lower bound. So yeah, guys, this was all from this question. Thank you so much, guys. Make sure hit the like button, press the subscribe button, and share with them. Thank you so much, guys. We shall see you next time.